Hello, children. How are you? I hope you all are fine and going on well with your studies. Students, this is my fourth video on electricity, and today I'm going to explain combination of resistances in an electric circuit. Students, welcome. Welcome to our science channel Sandeepan E.learning. Let's start. Students, various resistances or electric loads can be connected with one another in the following ways, either in series or in parallel. And here, for resistance, electric bulb is taken. And students, if we observe an electric bulb, then we can see that inside an electric bulb, there are two brass terminals. The upper end of the brass terminals are connected by a thin wire of tungsten. And if these two brass terminals are connected to a dry cell, then the bulb starts glowing. Students, in this picture, a bulb is connected to this circuit. And students, these are the two brass terminals inside the bulb. And these two brass terminals are connected, the upper end of the two brass terminals are connected by a thin wire of tungsten. And this thin wire of tungsten is also spiral in shape. And student, these two brass terminals are connected to this circuit, to the cell of this circuit, that one of its terminal is connected from the lower end of the bulb case to the negative terminal of the cell, whereas the other brass terminal is connected to the positive terminal of the cell from the side of its bulb case. And student, as the switch of the circuit is on, so electric current is flowing through the circuit and the bulb is glowing and or emitting light. Students, when electric current is flowing through this path and reaching this brass terminal, then here when it is crossing this thin wire of tungsten, then it is having or it is facing a huge amount of friction. And to overcome this friction, some electrical work is necessary to be done here. And the electrical energy which is spent to do this electrical work is converts into light energy. Students, we know that the resistance of a conductor is inversely proportional to the cross-section area of the conductor and directly proportional to the length of the conductor. Students, this thin wire of tungsten, for having a small cross-section area, it has a high resistance. And not only that, this wire, though it appears small in size or short in size, but for being spiral in shape, it is having a considerable length. And for this length, it is having also high resistance, because we know that if the length of the conductor increases, the resistance also increases. So students, when electric current is flowing through this thin wire of tungsten, this tungsten wire, due to having a high resistance, offers a friction to the passage of electric current through it. Means when electric current is passing through this tungsten wire, it is facing a friction. And to overcome this friction, some electrical work is necessary to be done here. And the electrical energy changes into light energy. So students, it is the resistance of the tungsten wire of an electric bulb which helps it to glow when it is connected to an electric circuit. So students, now we study that when more than one electric bulbs are connected either in series or in parallel to a circuit, then what is the effect of their resultant resistance? Students, in a series arrangement, Bulbs are connected to the dry cell such that the positive end of one bulb is connected to the negative end of the other bulb. And we say that the two bulbs are connected in series. And when the circuit is closed, the two bulbs glow dimly. Students, here you see in this picture, one bulb was connected beforehand. And when the second bulb is connected to the same circuit at the same level, and see how the second bulb is connected. One of the brass terminal of the second bulb is connected to the negative end of the first bulb, and the other brass terminal of the second bulb is connected to the dry cell. And as the switch is on, so current is flowing through the circuit and both the bulbs are glowing simultaneously. But one thing you notice here, students, that both the bulbs are glowing little dimly, not at such a brightness in case when it was only one bulb in the circuit. And if this way another bulb or third bulb is connected at the same level to the same circuit, that way that one brass terminal of the third bulb is connected to the negative end of the second bulb and the other brass terminal of the third bulb is connected to the negative terminal of the cell. And as the switch is on and the circuit is closed, so electric current is flowing through the circuit and all the three bulbs are glowing simultaneously but dimly. When the bulbs are connected in series, the resistances add up and hence total resistance increases. And with the potential difference remaining the same, the current flowing in each bulb decreases and hence the bulbs glow dimly. As to students, in conclusion, it is written that when the bulbs are connected in series, the sum total of resistances in series increases with the increase in the number of bulbs. So, the current flowing through each bulb decreases and each bulb glows dimly. The bulbs in series work simultaneously in the circuit. If the circuit is broken anywhere between the bulbs, then none of the bulbs glow. Next, students, the resistances in parallel. Students, in parallel arrangement, bulbs are connected to a dry cell directly. The bulbs are connected to the dry cell such that one point of each bulb is connected to the positive end of the dry cell and the other point of the bulbs is connected to the negative end of the dry cell. This kind of arrangement is said to be in parallel, and when the circuit is closed, the two bulbs glow with same brightness. Two bulbs, not whatever be the number of bulbs connected to the same circuit. In this way, means in parallel arrangement, will grow with the same brightness as in case of single bulb. Because students, in parallel arrangement, the resistances is divided and hence it is decreased, and as a result the current drawn from the cell is increases and all the bulbs which are connected to the same circuit in parallel arrangement glow with the same brightness. Students, here in this picture it has been shown that the two bulbs are connected to the dry cell at different levels and both the terminals, brass terminals of both the bulbs are connected directly to the two terminals of the cell. So when current is flowing through this path, it is facing only the resistance offered by the first bulb, and crossing that one, it is coming back again. And the current which is facing at this level, it is facing the resistance offered by the second bulb only. And after crossing this one, it is again coming back to the negative terminal of the cell. So though the potential difference at the end of the circuit remains same, but as the resistances are divided at two levels, so it decreased. Hence, the current flowing this circuit increased, and the bulbs are drawing currents directly from the cell. For this reason, both the bulbs are glowing with the same brightness. And in this circuit, if another bulb is connected the same way, means the two terminals of the third bulb is connected directly to the two terminals of the cell, then the third bulb, not only the third bulb, all the three bulbs will glow with the same brightness. So students, this way, in parallel arrangement, the total resistances get decreased because they are divided at different levels, and hence the current drawn from the cell increases. As a result, all the bulbs are glowing with the same brightness. And students, if there appear any break in the circuit, then it will have no effect on the working of the other bulbs. The electric current will only abandon this path, taking the other part, the current will cross the circuit and return to the negative terminal. Only the second bulb will stop glowing, and two other bulbs, they will glow with the same brightness. Because if there is any break or open at any level in the circuit in this type of arrangement, that break in the circuit will have no effect on the functioning of the other bulbs. So students, this is one of the most convenience in this type of parallel arrangement. So students, in conclusion, it is said that the sum total of resistances in parallel decreases with the increase in the number of bulbs. So according to Ohm's law, more current is drawn from the cell, and current passing through each bulb remains the same. So bulb glows with the same brightness. And in parallel, bulbs work independently, independently in the circuit. And if the circuit is broken anywhere between the bulbs, the remaining bulbs keep glowing. So students, this way, the resistances are arranged in an electric circuit. So students, I hope you understand. If you have any query, you can send that one in the comment box. Thank you students. Keep watching.